blocks are arranged in such a way that I can show you. Okay, just a minute. Yeah, it's fine now. So this is a this is a ground or a surface. Okay, this is a surface over where these two blocks are placed. One block is of mass 5 kg. So this is placed like this, right? And another block, this is of 5 kg, and another block which is in connection with the this 5 kg block is just placed, which is just in contact, right? This block is like this, right? This block is of mass how much? 2 kg. 2 kg, right? Now a 10 newton of force is applied from left side onto the first block, that is of 5 kg, right? So this force which is applied on 5 kg is of magnitude 10 newton. 10 newton. Now we need to find the contact force between these two blocks, right? So just to find the contact force between these two blocks, it's also given that there is no friction. So it have been given that no friction. So this surface is not applying any friction on this arrangement, right? So what will be the point of, what will be the contact force? Okay. So since these are the two masses, okay, the contact force will be lying over here, okay, between the point of contact of two blocks. So here lies the contact force, isn't it? This contact force will be lying just in between the blocks. So let us do one thing. Let us draw the free body diagram of these two masses separately. Okay. If this contact force which is lying between these two blocks is of magnitude F, right? Then this force will be acting by 2 kg on 5 kg. So F, when we consider for 5 kg, let us draw the free body diagram to understand very. So this is the mass of 5 kg. So we are drawing the FBD of 5 kg mass. Okay. So what are the total forces acting on it? Let us see. 10 Newton from here left, right? 10 Newton is applied from left, and the contact force, this contact force will be applied by this 2 kg mass on this, on the first mass, the bigger block. So this will be acting from left side, right? So this will be F, the same F, right? Now what will happen? Due to the application of this bigger force, this block will be moving into the right hand side, right? So when the block will be moving, entire arrangement will be moving into the right hand side with an acceleration, let us say A, right? Then we can say that this force, the due to this acceleration, this m into a will be acting into the right hand side. So the equation of motion which we can derive is that 10 minus f equal to ma, right? So this will give you the equation 10 minus f is equal to 5a. Why? Because m is 5 over here, right? So this is the equation which we derived. This is one of the relation which we will use to deduct the contact force, right? Yeah, and let me know please. And when you consider the second body and draw the free body diagram of 2 kg mass, right? What happened? This contact force will be applied by 5 kg on 2 kg. So the direction of force will be from right hand side, from left hand side on this. Yeah, what is the mistake? Let me know. If you are mentioning, I am happy to learn. So this contact force will be applied from left hand side, and since the entire movement is happening and acceleration of with an acceleration of a, then this mass is also moving with m into a. But here my mind it, this m is 2 kg, right? So the as per the free body diagram of 2 kg mass, we conclude the equation. What's that? It's going to the left, then it should be going up this side of the 4. Okay, no worries. Let me solve this, then we can discuss on it, right, Elaine? So here you can see, from here you can easily correlate that f is equal to ma, right? But here, Ellen, we will definitely discuss on it. Let me solve it first. Okay. I request your presence. Okay. So F equal to MA, or here since M is 2 kg, then F, this contact force, is equal to 2A. So this is the second relation which we derived. F equal to 2A. Now do one thing, just put up this value of f into this above equation. When you put up this value, then what will happen? This 10 minus f, this 10 minus f equal to 5a will give you 10 minus, in place of f write 2a, because we are substituting the value of f over here, this f, right? This is the same f over here. So 10 minus 2a is equal to 5a, right? Is equal to 5a. So this will give you, when you solve it, this will give you 10 equal to 2a plus 5a, and this will give you 10 equal to 7a. And when you move forward, this will give you the value of a equal to 10 by 7. So the acceleration of both the masses is decided, and we have concluded it, we have derived it, and the value of that is 10 by 7, let's say, meter per second square, right? Now this a is known to us. We are going to find the contact force. Now we will use again the first equation, that is, since this was the equation number 1, right? Let's say this was equation number 1. So this was also equation number 1, because both of these are the same equations, you can see. Now putting this value of a into equation 1, put value of A, that is your acceleration, in 1, that is equation 1, what we will get? 10 minus 10 minus f is equal to 5a, right? This will give you 10 minus f is equal to now here just substitute the value of a, right? 5, then in place of a write 10 by 7, right? So f will be equal to 10 minus 5 into 10 by 7. We just brought this 10. Now we leave this 10 into the LHS and push this force from LHS to RHS and brought this the constant term 5 into 10 by 7 from RHS to LHS, right? So this will give you the value of contact force as 10 minus 50 by 7, right? And when you just take the LCM and multiply, this will be 10 into 7 minus 50 by 7. So this will give you 70 minus 50 by 7, which will give you 20 by 7 Newton, which is the value of F, and this is the contact force between the two masses. F is 20 by 7, 20 by 7, right? The value of F is calculated as 20 by 7 Newton. So and this is the contact force between the masses, right? Yes, I hope you understand the solution. So from the very beginning, let me explain it again. This was the arrangement: 5 kg and 2 kg, two blocks were there. A 10 Newton of force was applied on it. So the contact force we need to calculate in the shown arrangement. So the contact force will definitely produce when the two bodies are coming into contact. So this is the point, this is the line through which the bodies are coming into contact. So contact force will be developing over here. We need to find the value of this contact force. And it's also given that there is no friction. So we draw the free body diagram of both the masses 5 kg and 2 kg. And when we draw the free body diagram of 5 kg and 2 kg, you can see 10 Newton was acting directly on 5 kg, so that we have considered. Now the contact force will be acting by each of the mass on the opposite direction and acting on the another mass. So due to this 2 kg, this F of contact force, this F contact force is acting into the left side on the block. You can see the direction. And since due to this 10 Newton force, this entire movement is happening. Let's say this entire movement, this arrangement of blocks is moving ahead with an acceleration of A. Now what we did, 10, just this MA will be considered, right? This is the resultant force. Now 10 minus F will be equal to MA. From the from the from the free body diagram of the first body, we concluded this equation number 1. Now again we draw the free body diagram of the second body, that is 2 kg. And here, as I said, the contact forces will be acting into the opposite direction. So here this contact force will be acting from left hand, because that is the 10 kg, the 5 kg mass is placed over here, you can see. So this will be applying to the right side, this will be applying to the right side, right, between on this layer. So definitely this will be the contact force, and thus entire system arrangement of blocks is moving with the acceleration of a that we have considered, then ma is the resultant force. That's why F is equal to ma, and when m equal to 2, F equal to 2a is the another equation which we derived. Now what we do, since F equal to 2a, just put up this value of F into the first equation to get 10 minus F equal to 5a will give you 10 minus, will give you 10 minus 2a equal to 5a. When you solve it, you get the value of a as 10 by 7 meter per second square. Now put the value of a in equation number 1, that is 10 minus f equal to 5a. So in place of a, what we put, tell me? Definitely this deducted value 10 by 7. So putting up this value, we get the value of F as 20 by 7 Newton, which is the contact force between the two blocks, right? Now let us come. I hope you like this solution. If you find it useful, you can just like and subscribe. Thank you so much. Yeah, I'll end. The pianist is going to the left when it should be going up on the side of the 4. So gravitational pull on the planet of Earth, which makes the 2 kg lighter. No, 2 kg will be lighter definitely, but here we are considering the horizontal component of the forces, right? So if you can see, if you need to equate the horizontal component of the forces in acting into the left will be equal to the total forces acting into the right, right? So here you can see the horizontal component of the forces only considered, right? This one, and there is no friction, so that's why this will be the solution which will be, which is correct. And here we are able to conclude the value of contact forces, right? It's not like there is no vertical motion happening, right? So I think that gravitational fundamental or application will not happen over here, right? So students, I think you find the solution useful. For any query, you can put up into the comment box. Yes, I'm always there to help you. Thank you so much for watching. Take care. Bye bye.